do that same process where we draw each of the graphs separately. So if I was to draw y equal 2 plus 1 over x cubed, so I'm just going to tell you what I'm thinking. Y equal 1 over x cubed is like y equal 1 over x, right? So that's like this. And then to shift it up by 2, that's going to change where the horizontal asymptote is. So that's going to be at 2. So it'll be here and here, right? Just, you don't have to draw this part. I'm just going to help you into like how to think about it. So then what part of that graph do I want? I want the part of that graph where x's are smaller than 0. Oh, okay, so that means I want this. So I'm going to draw this separate solution graph. I'm going to put the horizontal asymptote here at 2, just like that. Now let's go and do the other graph. So I want the y equal x minus 2 to the 4th. You know, to the 4th power, that means it's like a parabola. X minus 2, that means to the right by 2. So it kind of looks like that. So what part of that graph do I want? I want when x's are bigger than or equal to 0. So I'm going to be putting, I don't know where that y value is. So let's put in x equals 0 into here. So I would get 0 minus 2 to the 4th. Oh, I think that gives me 16. Way up here, right? 16, and it looks like that, where it crosses here at 2. That's a function, right? So because it does pass the vertical line test. Okay, I did make mention of this fact, so here it is. So really, the graph of this is like saying the graph of that. Hey, I know that. That's the absolute value of x. So what part of that graph do I want? When x's are smaller than negative 1. We'll circle back. Again, I want you to make up a separate graph. Make that better. It's crunched in here. Separate graph of the solution. So back here at negative 1. And up there. So what is that y value right there? Oh, if I put negative 1 into here, I get a y value of 1. Alright, so let's go do the other graph. So the other graph is y equal x to the 2/3. So I'm getting really familiar with this graph, right? And I want the part of that where it's less than or equal to negative 1. So that, I'm sorry, I said that wrong. Greater than or equal to negative 1. So I want that point, and I want all of that that's bigger, right? What's that y value? Hey, wait a minute. If I put in negative 1 into here, I square it, I get 1. Cube root it, get 1. So that closed dot goes on top of the open dot, so the closed dot wins. So it looks like that. Okay, here we go. Here we go. So I'm going to do this, which is really, really similar. Remember I talked about x over the absolute value of x? I called it that graph. Okay, remember what that graph was? 1, negative 1, right? I think that's the same thing. So let's think about this. Because I know the square root of x squared is absolute value of x, this gives me 2 minus x over the absolute value of 2 minus x. I know, because I can think about it, I cannot use x equal 2. Okay, so let's try numbers on either side of 2 to see what's happening. So if I plug in an x equal 3, I get a 2 minus 3 over an absolute value of 2 minus 3, negative 1 over the absolute value of negative 1. That gives me negative 1. Okay, what happens if I choose 4? I get 2 minus 4 over the absolute value of 2 minus 4, negative 2 over the absolute value of negative 2, negative 2 over 2. That gives me a negative 1. Okay, so I think I'm getting the idea because I have a basic idea that it's that graph. So let's look at it. 2 is the point that I cannot use. But if I plug in 3 and 4, I get a y value of negative 1. So it's down here. So all the way up to 2, I'm down here at the y value of negative 1. So checking some other points. So what happens if I plug in x equals 0 or x equals 1? If I plug in x equals 0, I get 2 minus 0 over the absolute value of 2 minus 0. That's 2 over 2. That's 1. So that's up here, right? Oh, sorry. X equals 0 is 1. If I plug in 1, I get 2 minus 1. The absolute value of 2 minus 1, that's 1 over the absolute value of 1. That's 1. So here it is. So it has an open circle at 2, right? So it's that graph, only it's moved around a little bit, right? Okay, so what part of that graph do I want? Oh, I want all of it except x equals 2. Well, that's like everything, right? So let me make room down here so I can just make it neater. So I want this graph to, it has up here at 1, down here at negative 1. Then, what does this part say here? When x equals 2, put in the y value of 3. Oh, look at that. We'll put 3 up here, and we'll have a flying dot. And that is a function because it does